important for you to know that this whole angle here, that reflects there, okay, it's going to be 360 minus 2x, right? Therefore, angle R1, okay, R1 is going to be half of 360 minus 2x, it will be 180 minus x, okay? Which means I can easily determine the size of R2 in terms of x, okay? Furthermore, if you look at this whole shape here, right, I can determine the size of this angle. Okay, it's an angle at the center, and that angle is going to be 180 minus 2x. So obviously, because OP is a radius, OS is also a radius, P1 is going to be equal to S1. But that's a very long route. The easiest is just to say 2x is equal to P1 as S1. Okay? Which means P1 and S1, they are both going to be x. Okay, but let me just write it down nicely. Okay? So first thing I'm going to say, the way you do it is going to be slightly different from me in terms of the layout. Okay, so I'll start by saying OP is equal to OX. And I'll say these two are what? Are rather. Okay? Then I'll say in triangle POS. Okay? 2x is an exterior angle. Okay? Therefore, it's going to be equal to P1 plus S1. Okay? And my reason here is going to be exterior angle of triangle. Right? Okay? So let me remove this mask. Is there anybody who saw the way that I'm doing it? Okay. All right. So from here now, we know that P1 is going to be is equal to S1. And the reason for this is angles opposite equal side. Okay? So what that means is I can put P1 here, or I can replace the S1 sorry, I can put S1 where there's P1, I can also put P1 where there's S1. Therefore, I can write here and say 2x is equal to 2P1. Okay? So what this means is that P1 is equal to x, and S1 is also equal to x. Okay? Are you following that? Huh? Yeah. So we have covered almost like 2/3 now of the question because we're supposed to determine three angles that are equal to x. So already I've explained to you that this angle is equal to 360 minus 2x. But that could be a very long route. Okay, the shortest way is just to say P1 is equal to R2. The exterior angle of a what? A cyclic path. So that's what I'm going to do. But it's not the only way of finding R1. You could take a long route of finding the value of R1, which you can say 180 minus x. Then you subtract that 180 minus x from 180 to get x for R2. Or you can determine the size of this reflex here. It's an angle at the center. So it is twice R1. Then you have to determine R1 first, then use angles on a straight line, you still get R2. Okay, so there may be three ways of getting the value of R1, but the shortest is just to write here P1 is equal to, or rather, and let me write this R1. So R2 rather. So I can write this as R2 is equal to x. And my reason here will be exterior angle of cyclic path. Okay? That's the easiest. Okay, and the shortest way. But if you don't see an easier way, then you might have to go via the long route. There's no other option. Okay? Any question there? Any question? Okay, just to let you know that also you can find S1. I'm sure you can see that on this diagram here. OM is a radius. OS is a radius. So triangle MOS is an isosceles. So you can subtract the 2x from 180, you get 180 minus 2x. Then since M1 is going to be equal to M2 because they are angles opposite equal sides, you can find the size of S2 in terms of x. Then the whole angle S1 plus S2 is equal to 90 degrees because it's an angle subtended by a diameter. Okay? You following that? Please be part of the lesson. Okay? Be part of the lesson. Right? So you determine what? S2. You subtract S2 from 90, you will get S1. Since POS is an isosceles, S1 is equal to P1, then you can carry on that way. That's another route. That's why I was asking, how come you all saw it almost the same one? Then, I think to determine R2, there are probably two ways. Either you can find R1 first, you subtract from 180, you get R2. Or you can use exterior angle of a cycling part. Okay. In most cases, some geometry questions may have more than one way of getting to the solution. Okay, in most cases. All right, you see that it's not difficult. Huh? Am I talking to myself? Okay, let's move on to 3.2. Okay, so 3.2, we now need to express S2 in terms of x, which is part of what I just said. Right? So it's probably easier now because we know what P1 is. So 3.2 is going to be very easy. So S1 plus S2, they add up to 90 degrees. And the reason will be angle in a semicircle. Please, it's not angles in a semicircle. No. It's one angle. Therefore, it's angle in a semicircle. Don't say angles. There's one angle which is subtended by the diameter. Not two angles, one angle. Right? So here we know what S1 is. So S2 is going to be 90 degrees minus S. Okay, you see that it's easy. Even though you saw how the diagram looks like, but doing the questions is easy. You know your stuff in terms of your geometry concepts. That's why I always say don't be scared because you saw the diagram for the first time. Sometimes the diagram might look complicated, but when you start looking at it in more detail, you find that the questions are easy to actually do. Right? Then 3.3 SROM, okay, is a cyclic quadrilateral. Right? Is that true or false? So you need to prove that SRMO is a cyclic quad or not. Okay? So in this case, I won't rush to say it's true or false. Right? I have to go back to my basics of proving that a quadrilateral is cyclic. There are three. Converse of theorem 4, which in this case is not applicable because we don't have a butterfly. Okay? So the converse of theorem 4 is out. Then theorem 5, opposite angles, a cyclic quad. So we just have to prove that the opposite angles add up to 180 degrees. If that's true, then you can say therefore it's a cyclic quad. Okay? Now, also, we can use the converse of theorem 6. An exterior angle of a cyclic quad should be equal to an interior opposite angle if it is a cyclic quad. Okay, so I've got two ways of doing it, of doing this question. So what I'm gonna do, allow me to just show you both ways. Let me start with the converse of theorem 5. Right? So 3.3, this could be method 1. Okay? So first, you have to decide which two pairs of opposite angles, you want to prove that they add up to 180. For this question, it's much better to work with 2x and R1. It's much better to work with those. So what I would do there is say R1 plus R2 is equal to 180 degrees. These are angles on a straight line. Okay? These are angles on a straight line. Okay? Now, R2, we know that R2 is x already. So, R1 is equal to 180 degrees minus x. Okay? And we know that SOM or MOS, MOS is equal to 2x, and this is given. Okay? So, if we add R1 and 2x, we should get 180 if SRMO is a cyclic part. So let's check that. Okay? So we'll say 180 degrees minus x plus 2x. Okay? This should give us 180 degrees. If it doesn't give us, then we'll see. So here, if I take the 180 to the other side, well, the best way is just to write it as 180 degrees plus x. This is not equal to 180 degrees. Okay? So if I add the angle R1 and MOS, I don't get 180 degrees. Therefore, SRMO is not a cyclic part. Okay? Well, in this case, because of the nature of the question, we can probably give a reason. Why? Because opposite angles of the cyclic part are supplemental. Okay? Right? But you must understand that I'm just writing something that I've already written here. Okay? Here. I wrote that if I add these two, I must get 180 degrees. But here I just wrote it as a statement. Okay? So even if you don't write that, you make that conclusion afterwards showing this working out. You should deserve what? 4 marks. Alright? So let's move on to the second method. The second method is just to prove that R2 is not equal to 2s. If SRMO was a cyclic part, then R2 is supposed to be equal to what? 2s. So that will be a shorter way though. So method 2, right? So I'm saying R2 is equal to x. And then MOS is equal to 2x. Then you say, since R2 is not equal to MOS, okay, it therefore means that SRMO is not a cyclic part. Okay? It's not a cyclic part. Okay, maybe you can add here and say because an exterior angle of the cyclic part is equal to an interior opposite angle. Okay. So, also I need you to be aware, the fact that we say true or false here, maybe we should write somewhere that it's false. Okay? How did you answer to that part? You said false. Did you give a reason? Huh? You just said false, then did you give a reason? Okay. So maybe you say false somewhere. So this is false. But I think even if I'm a teacher, is that if a learner that does not write false, but they write this, that reason makes sense. Makes sense. Right? So it's false. Then here we have to write something that therefore here we get that therefore it's false. I'm showing that. It's not really that important. We stop here after writing all these things that should be fine. This one here we can write and say proved in what? In 3.1. And that one there we say it's given. Because it's 4 marks, remember, the question is 4 marks. So to get all the 4 marks, you must provide as much information as possible. Alright? Okay. Something like that.
If I didn't use MOS, but on the diagram I specified which was O1, which was
Yes,
O2.
please put therefore here. Therefore it's false. Okay, yes?
If I didn't use MOS, but I labeled on the diagram what O1 is and O2 is that okay?
Yeah, you see, in that case now, I have to see your diagram. If whatever is on your diagram is also what you wrote, there's a relationship, then it will be fine. All right. Any question? Okay, if you don't have a question, then let's carry on.